Okay, I'm going to talk about developing a network diagram. Here are the different steps of developing a network diagram. You define the activities, then you order the activities on the project, you establish the activity relationship and draw a network diagram. You determine quantities and assign durations to the activities, assign resources and costs, calculate early and late start or finish times, compute float words, values and identify the critical path, and schedule activity start or finish times. So while developing a network diagram, you go through all these steps. So you are going to identify what are the activities in your project, at which order they will be done, then what are the relationship between the different activities, um, determine quantities and duration, like what's the magnitude of the activity, how long the activity is going to take, what resources, manpower, and costs each and every utility activity will take, and what are the starts and finish times, and if there are any float values in it. Defining activities, anything that must be accomplished whether by the owner, contractor, or subcontractor, supplier, or other party in order for the project to be completed may warrant inclusion in the network. One must recognize the different types of activities that can come into play in a construction project. And so, activity is anything that needs to be uh, accomplished. You see, anything that needs to be accomplished either by the owner, by contractor, whosoever is doing that with a start and end date, that is considered an activity. Ordering activities. The sequence of activities in a schedule is based on the occurrence of activities. This is simply a logical progression. Uh, so you need to look into which activities must precede the others, which activities must follow it, which activities can be concurrent with it. So the ordering of the activity is very critical. You have to look at it in a logical way. Which activity will come first, which activity will come later on, and what activities can be done in parallel. For example, let's assume while you are constructing a refinery. So you know that you are going to start first do the site preparation and then you start doing the construction. So while you are doing those activities in that order, at the same time in concurrent, you might order certain materials such as generators, turbines for your refinery. You can do that in parallel. So that would be a concurrent activities. Resource constraint. These constraints are conditions of limited resource availability that dictate that certain activities cannot be performed simultaneously. For example, the availability of only one crane for two otherwise independent activities might require them to be scheduled such. Similarly, the amount of concrete that be placed in a day may be dictated by the production capacity of the concrete batch plant. So resources constraints might be there. There could be a constraint of manpower resources. You have limited manpower resources, and there are those manpower resources on working on multiple projects. So, so there could be a resource constraint. At the same time, let's assume that you have one crane available, and that crane is a resource. Now, if the crane is being used on multiple projects, that will be a constraint. Financial constraints. Monetary constraints can include the staggering of high-cost activities to minimize cash requirements during construction or the necessity of securing loans prior to undertaking certain projects or large cash flows items might also be scheduled so that they are incurred in a particular tax year. There could be financial constraints. Those constraints can be included. Um, these constraints, financial constraints would be there, can be on the project that hypothetically speaking, there is a possibility that the cost of material might have increased. So once the cost of material goes up, There could be financial additional constraints which was not part of the initial plan of the project. Contractual constraints. The owner may impose constraints on the construction process. As an example of this type of constraint would be a project where the owner requires the work in one physical location to be completed before the work is in another country. This is often true on road projects or airfield projects where project phasing is dictated in contract or in multiple building projects such as medical complex or school or the owner of condominium may require that a construction. So contractual constraints should be such that may be such that um, the owner of that project, that person, let's say there is a commercial project. So in that commercial project, the owner of that commercial mall might say that to start with, let me at least construct the shops on the front, maybe at the restaurants in the front. And once those are completed, I can rent them out while the construction work on the other shops is going on. So that is a contractual constraint which the owner might put in the contract. In the initial definition of a network, it is desirable to minimize the number of constraints introduced in the network during the ordering of activities. This is because the introduction of excessive constraints in the network can have the following impacts on the project: reduce schedule flexibility, lengthen project duration, generally increase project cost, confuse basic scheduling logic. So you have to be careful in putting different type of constraints, excessive constraints, because it will impact the scheduling of the project. If there are more constraints, then it will reduce the scheduling flexibility. The precedence diagram depicts activities as nodes with logic link lines that depict the dependencies that exist between the activities. The relationship of the activities in a precedence diagram are conveyed with relative simplicity of the logic links. Simple example of a precedence diagram for erecting a concrete wall. For example, you is the first activity, you have a layout of the wall. Then you place rebar. Then you erect wall forms. Then you tie the rebar. Then you check wall forms. Then you place concrete. Example of a precedence diagram for construction a concrete footing. Here is an example of precedence diagram. It shows which activity precedes the other. That's how we came up with the name precedence diagram. Lay out foundation, then dig the foundation. In parallel, you obtain rebar. Then you place formwork. Then you cut and bend rebar. Then once you have done in parallel, then you place the rebar. Then place concrete. While you are placing rebar, you are obtaining the concrete. So you have obtained the concrete, you place the rebar, and you place the concrete. Assigning duration to activities. The duration of an activity is the estimated time that will be required to complete it. Typically in construction, the unit of time is days, and it is assumed the work is performed on a continuous and uniform basis with the standard workday and work week. The time might also be measured in months, weeks, shifts, or even hours. So in the construction industry, the durations of activities usually in days or weeks. So you use that as the standard. The early start time of an activity, in simplest term, using CPM with resources and costs permits the amount of each resource needed during specified time period to be examined. Beyond this, there are activity. The early start time of an activity is the earliest time that the activity can begin based on the relationship that exists in the schedule. The late start time is the latest that an activity can start without adversely impacting the date of the project completion. Similarly, early finish, the earliest that an activity expected to be completed, and late finish is the latest that an activity can be completed. So, early start is the earliest that you can start the activity, because you see that activity might be dependent on other dependent activities. So that's the earliest you can start. The late start is the latest time you can start the activity. Similarly, the earliest finish would be the earliest you can finish as compared to the other activities. Those activities could be precedents and they might need to be finished earlier before this activity finishes. To identify the critical path is very important. In the early and late start dates of an activity are the same, it is evident that the activity has no flexibility of flow. In other words, if the activity starts later than the assigned date, or if the activity takes longer to complete the assigned duration, the project completion date will be extended by the same amount of time. When activity is fixed, in this way, the activity is said to have no float. Such activity is said to be critical, meaning that any delay in the start date or completion date will extend the project duration. The critical path is the path from the beginning of the network to the end of the network on which all activities are critical. So critical path method is to identify the path of all the activities, uh, and so all those activities will be critical. If there is a delay in any of those activity, then there will be no float in it and the whole project will be delayed. In the precedence diagram, activities are represented by nodes. The nodes are linked by lines that show the relationship that exists between the activities. While the diagram represents only basic information of the construction of a pole barn, the logic should be apparent. The diagram is read from left to right and the linked line shows clear dependencies. Precedence diagram of a simple pole barn. So layout pole location, it's an activity. There's the link of the activity. Dig holes and set poles, set trusses and no roof form, install siding, install roofing. Limitation no longer poses a constraint. Other types of relationships are also included, namely start to start, finish to finish, and start to finish. In a finish to start relationship, the start of each activity depends on the completion of its precedence activity. So finish to start, when the previous activity finishes, it starts. This is if an activity depends on another, it will not be of a start until the precedence activity is completed. For example, a door jamb must be installed before the door can be hung. Similarly, footing excavation can be completed. A typical sequence of finish to start relationship, meaning place concrete 1 day, cure concrete 28 days, strip concrete forms 2 days. This sequence seems quite logical. The activity cure concrete is typically one that does not entail the use of resources other than time itself. So cure concrete, this is a finish to start. So place concrete has to finish, then the cure concrete activity will start, there, which will be 28 days. Then cure concrete activity will finish, then strip concrete forms activity will start. Limitations no longer poses a constraint on or concern. Other types of relationships are also encountered, namely start to start, finish to finish, and start to finish. In a finish to start relationship, the start of each activity depends on the completion of precedence activity. That is, if an activity depends on another, it will not be able to start until the preceding activity has completed. Another relationship that occurs in construction is start to start with a delay. First, consider the construction of a simple stud wall that will receive insulation and drywall. It is assumed there is no plumbing electrical. Suppose several rooms are being constructed in the building. Here, start to start. In this, you remove old flooring, you clear the debris from the floor surface, then you spread grout, you're spreading grout, set tile flooring, and clean up the floor. Basics about precedence diagram. Precedence diagrams are easy to draw, and it is a simple procedure to add an activity to a diagram. Viewing a precedence network diagram, it is important to avoid confusion linking lines with activities. The linked lines represent dependencies only. Delay between two successive activities can be represented on the link line example in this trust. Calculations on a precedence diagram. The most tedious yet most important aspect of a network model is that the permit planner or scheduler to calculate the total time project is projected to take and time at which each activity and must start in order for project to be completed. While in practice, most calculations are not performed by scheduling, so it's important to understand how a scheduler works. In project management, free float and total float are both measures of how much time a task can be delayed free float without affecting the project. Free float, also known as slack, is the amount of time a task can be delayed without affecting the start of its next time task. Measure of task flexibility. So you have an activity that is going on. Even if you delay the activity, then how long you can delay it without impacting the overall project's delay. So this difference of time is called float, free float. Total float is the amount of time a task can be delayed without affecting the total final complete. Total float is important for managing project uncertainties and variations. Final comments. The network type of choice of many construction professionals is the precedence diagram. Once the logic is worked out, the values of early start, early finish, late start, late finish, total float, free float of easily compared. These values serve as the basis for making various type of management decisions. With this information, projects can be monitored and controlled. With the detailed scheduling information about each activity, informed decisions can be made when the need arises to accelerate the schedule, make change in network, or redefine the scheduling logic. So with all these uh, logical diagrams, especially the precedence diagram, and the project managers can very logically look at the project and see where how the project will proceed, how they can manage it, how they can control it, so they can put different milestones at different stages of the project, and each milestones they can measure at those gates to check how well they are doing. So that's the advantage of precedence diagram. That's all for now. Thank you.